welcome back to the class of Surds. From our last session, we had Surds, we described what Surd is and we give examples. In this one, we want to continue with the other part, which is the positive square root, how to compute the positive square root of Surds. We will generalize this so that we can now take at least an example. If we want to compute the positive, all the possible square root of root a plus or minus b. Let's assume we will take the positive side. Since this is the same argument with the negative sign too. So we take one, we leave him to go and take care of the other part. If we are taking the positive part of this now, we have a plus root b. We want to look at a form of solution that we will get. And by so doing, we can assume a solution of root x plus root y. Following this approach, we want to get the values, we compute the values of a and b, and by solving that equation simultaneously, we will be able to get our values of x and y. How? Given this, okay, this is the square root of the given function, surd function. Now, in order to reduce this, I want to take care of this root first so that we can perform operation. What do we do? By squaring both sides of this given equation, let me call it equation star. By squaring both sides of equation star, we obtain, by squaring this, we have a plus root b. This will be equal to, if I square this, that implies that I am putting square here, I'm repeating this to multiply itself. I have x plus y plus 2 root xy. And from here, we can compare both sides of, let me begin to name this equation 1, so that our work can be neat and we can easily make reference. Now, by comparing both sides of equation 1, comparing both sides of equation 1, we have a, because this one is ordinary number, so we compare it with this. A is equals to x plus y. And we have root b equals to 2 root xy. But this one is still giving us additional headache, and we have to take care of it. What do? We square both sides of it. Let's name this. Let's continue to name this. This will be equation 2. I name this guy equation 3. But I'm not comfortable with equation 3. I want to reduce it further. What do? We square both sides of equation 3 again. By squaring both sides of equation 3, we now have b equals to 4xy. And we can continue from, we can name this one equation 4. By solving equations, we already have values for a and b now. So by solving equation 2 and 4 simultaneously, we will have the values of x and y as presented in the assumed solution. Okay, let me write that. By solving equations 2 and 4 and equation 4 simultaneously, we have the values, and we say we obtain the values of x and y. Let's put this to practice by at least one example. At least one example. We want to compute the positive square roots of 6 plus 4 root 2. To compute the positive square root of this, the square root of this is equals to root x plus root y, as we have in the generalized form. So, all the steps we have taken in what we just described now is what we will be repeating here. Only that this has now changed from our A and B to figures. Now, by squaring both sides of this, we have 6 plus 4 root 2, of course, equals to x plus y plus 2 root xy. And from here, by comparing both sides of, let me name this guy equation star. By comparing both sides of star, I don't want to be writing this since we already have it in the description we had earlier. So, by comparing both sides of stars, we have x plus y equals to 6, and we have 2 root xy equals to 4 root 2. Of course, this one is already okay. Call it equation 1. But we want to move further. We want to remove all the surds in this. Let's call this one equation 2. By squaring both sides of equation 2 again, we now have 4xy. If we square this, we have 16. We square this, we have 2. Therefore, this will become, this implies that 4xy now is equals to 32. Name this guy. Okay, we can even reduce this. We can reduce this further. If we divide both sides by 4, we can have xy equals to 8. So let's name this guy equation 3. By solving equation 1 and 3 simultaneously, we can now determine the values of x and y. From equation 1, we can have x equals to 6 minus y. Call this one equation 4. So by substituting 4 into equation 3, you know, we can solve simultaneous equation in different forms. We have the substitution method, the elimination method, graphical method. But here we are using the substitution method because it is not easy for us to use elimination here. Okay? So now, if we substitute 4, substituting 4 into 1, into 3 rather, substituting equation 4 into equation 3. We obtain, so 3 now becomes, instead of x now, we have 6 minus y multiplied by y equals to 8. So we are putting this one into this now. This becomes 6y minus y squared equals to 8. Okay? This looks quadratic already. We can rearrange this to have, that means we are taking this to the other side. We have y squared minus 6y plus 8 equals to 0. And from here, since this is quadratic, we can factorize this. Factorizing 6, we take the 2 factors of 6, that when we have minus 6. When we multiply, we have 8. And that will be nothing but 2, minus 2 and minus 4. So y squared now is equal, y squared minus 2y minus 4y plus 8 equals to 0. We have successfully changed the minus 6y here to minus 2y minus 4y. Okay? And if we factor y from the first 2, we have y left here minus 2. If we factor minus 4 here, we are left with y. And we are left with minus 2 here also equals to 0. We can see that y minus 2 is common. We factor that. We are left with y here, and we are left with minus 4 here. All of this equals to 0. When we have two things multiplying each other and we have 0, like I mentioned earlier, that implies that y minus 2 is equals to 0, or y minus 4 is 0. And therefore, y is 2 or 4. This implies that if I want to get, this is the values of y. If I want to get the values of x now, I can substitute back into equation 1. That is substitution method. Also, the substitution method for solving simultaneous equation. Now, substituting the values of y equals to 2 into, so we say when y is equals to 2, equation 1 becomes we want to get the value of x. X equals to 6 minus y. And if our y is 2, that implies this one is what? 6 minus 2, that will be 4. At y equals to 2, x is 4. Also, at y equals to 4, x is equals to 6 minus 4, which is 2. Therefore, all the positive square roots, all the positive values that we can get from that are, earlier on we have 6 plus 4 root 2. This one, we say it is root x plus root y. Now, if our x is 4, that implies that this will be 2. Okay, let's say root 4 plus root 2, because at x equals to 4, our y is equal to 2. And at y equals to 4 as well, our x is equals to 2. So any which way you pick, we have the same answer. Therefore, this guy here will be equals to 2 plus root 2, which is the required solution. I think since we are wrapping up our Surds class here, I would like to give us some questions to go and play with at our own leisure time. Exercise now. 1. Simplify. Root 8 plus root 50 minus root 18, all of this divided by root 32. That's 1. 2. Solve root 3x plus 4 minus root x plus 2 equals to root x minus 3. Please, at your leisure, please look at these two equations, two exercises, and let's hear back from you. We'll be looking forward to getting feedback. And even if you have some other areas of concern, you can drop them under the comment section, and you can be sure at any time you will be attended to accordingly. Thank you.